In the last video, we built a LangGraph agent with one graph, one agent node, and one routing function. And the agent handled everything, including searching, storing, calculating, all by itself. That worked really well. But think about what we were actually asking one LLM to do. Plan a multi-step research task. Remember to store intermediate values. Switch mental modes from find data to do maths in the mid-run. Handle all its own errors. We are asking one journalist to be a researcher, a data manager, and an analyst simultaneously. But it's proven that the specialized LLMs or agents perform better over journal ones. So what if instead of one agent doing everything, you had two agents, each with specific role, specific tools, and no access to anything outside their job? A researcher whose only job is to find population figures and store them, they have a web search tool and a memory store tool. They cannot calculate. That is all what their job is. A calculator whose only job is to retrieve those stored figures and compute the percentage. They have a memory retrieve tool and a calculator. They cannot search the web. That is all what their job is. Neither agent can do others' work. The role boundary is enforced at the tool level, not just in the prompt. So that's the actual mental shift in this video. So same task, same answer, but now there are two agents, two tool sets, and a framework coordinating the handoff between them. That framework is CrewAI. So let's build it. Let's start by installing three packages that we need in this session. The first one is CrewAI, which is the framework. CrewAI tools gives us the base tool, which is base class for custom tools offered by CrewAI. LangChain Grok is the same Grok integration we have used throughout this series. Now that we installed the packages, let's start by importing the necessary libraries. Now I'm pasting some code for setting up LLM. This is how we set up LLM with CrewAI. For video 4 and video 5, which was for LangGraph and LangChain, we used Chat Grok client to import and set up our LLM. Here we use CrewAI's own LLM wrapper, which we imported from the CrewAI framework. Under the hood, CrewAI uses Light LLM, which is a library that provides a unified interface to dozens of model providers. The model string format is provider/model name. So Grok models are prefixed with Grok/. Same API key, same model, but different way to instantiate it. We set up the value of temperature 0. For a research and calculation workflow, we want deterministic and focused responsive. We don't want any creative variation here because the researcher should look up the number and store it. The calculator should retrieve it and compute the answer. Neither job benefits from randomness. So I'm pasting some code here for defining the tools. You can see we have the same tools: web search tool, calculator tool, and memory tool. It's different from our previous videos because in LangGraph we define the function with tool decorator, but here they are different. They have extended the base tool class, which comes from CrewAI.tool, and each tool you can see has a name, description, and a run method. So each one is defined that way. But the memory looks completely different because I have split this into two functions. One is memory store tool and the second one is memory retrieve tool. In previous videos, we have one memory tool with a store and retrieve prefix in the input string. There was only one tool and two modes. Here I split them because the researcher only needs to store and the calculator only needs to retrieve. By splitting the tool, I can give each agent exactly what they need and nothing more. The researcher cannot retrieve and the calculator cannot store. The tool list is the job description. And then we instantiate each tool like this. Now let's define our agents. Let's start with researcher agent. So there are 4 fields. One is role, goal, backstory, and tool. Let's understand role first. The LLM receives this as part of its system context. When researcher's LLM is called, it knows that it's acting as a population research specialist. That shapes how it reasons, what it prioritizes, and how it writes its output. Next is goal. This tells the agent what it's trying to achieve on this task. So in this case, we are telling the agent that your goal is to find accurate population figures for Tokyo and Japan, then store both values in shared memory so the calculation agent can use them. Next is backstory. It's a crucial component of agent's definition that provides depth, context, and personality, significantly influencing how agent approaches the problems and interacts with the crew. So we are telling the agent that you are a meticulous data researcher who specializes in demographic statistics. You always verify figures with web searches before storing them. You never guess numbers. Your job is to gather and preserve data, not to analyze it. So we are giving it a persona and giving it strict information about what it is supposed to do and what is the background of it. We added a last sentence which is not to analyze it, because we are telling the researcher not to creep into the calculator's territory. Section is tools. A tool in CrewAI is a skill or function that agents can utilize to perform various actions. This includes tools from CrewAI toolkit or from LangChain tools or your own custom defined tools. This enables everything from simple searches to complex interactions and effective teamwork among the agents. So in this case, we have imported the tools this agent would need. Notice that we haven't given it any calculator or memory retrieval tool. The researcher cannot do anything outside these two tools. Let's build our calculator agent. We are giving it a role which is statistical analysis specialist, and then we are defining its goal, which says retrieve the population figures stored by the researcher and calculate what percentage of Tokyo's population represent of Japan's total population. Now look at the backstory. We are telling it that you are a precise analyst who works exclusively with numbers that have been verified and stored by the research team. And look at this section. We are telling it that you never look up data yourself. You trust the researcher's work and your job is to just calculate and clearly explain the result. So we are not just telling the agent what to do. We are also telling it what not to do and why. That prevents the calculator from deciding to run its own web search if memory values look unexpected. And next one is tool. You can see that we have defined two tools here. Memory retrieve tool and calculator tool, which means you cannot search because there is no web search tool, and you cannot store because we are not providing it with any memory store tool. This is the key architectural differences from everything we have done in this series. In video 3, 4, 5, we had one agent with all the tools. If that agent got confused between searching and calculating, there was nothing to stop it. It might search when it should calculate. It might calculate when it should research first, and it might calculate with the wrong numbers. Here, the confusion isn't possible at the top level. The researcher cannot calculate even if it tries. The calculators cannot search even if it wants to because they don't have access to the tools. We will define tasks for each of these agents. So I'm pasting some code here. We are going to define task for researcher agent. In CrewAI framework, a task is a specific assignment completed by an agent. Tasks provide all the necessary details for execution, such as its description, the agent's responsibility, required tools, and more. In short, a task is the unit of work, one per agent. Description is definition of what to do, and expected output field defines the definition of done. Expected output field is important. It's very important here because CrewAI uses it to evaluate whether the task is complete or not. If you write a vague expected output like provide the population data, you will get a vague completion. Be specific what keys should be stored, what figures should be confirmed. The expected output in this case for researcher agent is a confirmation that both population values have been found and stored in memory with Tokyo Pop and Japan Pop with exact figures retrieved from the web search. When only the agent would have this information, this task will be considered as completed. Now we move to the next task. We defined the calculation task. I'm pasting some code over here. Notice that we have additional field called context here. In CrewAI, the context parameter in task definition is a very powerful feature that allows the output of one or more previous tasks to be used as input for the current task. Context research task tells CrewAI before running this task, take the output of research task and make it available to the calculator agent. The calculator receives the researcher's full output as additional context before this begins this task. This is how information flows between agents without you writing any handoff code. You don't update a state dictionary like LangGraph. You don't pass messages. You don't route between nodes. You just declare which task's output a given task depends on. We have defined our agents and we defined their tasks. Now we are going to define Crew. Going by the definition of Crew in CrewAI documentation, it's a collaborative, structured team of specialized AI agents designed to work together to execute a set of tasks. So here we have our Crew defined. Agents that list all the agents in the Crew. Tasks list all the tasks and their execution order. Then there are Process.sequential means run task 1, finish it, then run task 2. That should be in order in a sequence. Verbose equal true, print the crew's orchestration logs. I want to mention briefly Process.hierarchical here as well, which is another process type, because you will see it in the docs. In hierarchical mode, a manager LLM is automatically created. You describe the overall goal and the manager decides which agent to call, in what order, and when to stop it. It's more flexible, less predictable, and harder to debug. Sequential is right tool for this task because the order is fixed. Research must happen before the calculation. There is no decision to make about ordering and all. Sequential is explicit and use it when you know the sequence. Use hierarchical when the task is open-ended enough that a manager needs to plan dynamically. Now compare this to what we have done in LangGraph video. In LangGraph, we built an explicit state graph. We added nodes. I'll go to here. We have the agent node. And then we build a graph. So we added nodes, we wrote edges, we wrote a routing function, we had 7-8 lines of code, we saw everything transitioning. Here we described the roles and tasks and let the crew handle the coordination, which is a way more easier than graph. The trade-off is LangGraph gives you full control and visibility into every state transition. CrewAI gives you role-based delegation with less code, but the internal coordination between agents is managed by the framework itself. You don't get to see every step, you see just the task outputs. Use LangGraph when you need to own every transition. Use CrewAI when role separation matters more than step-level control. Now we write our main block here. Crew.kickoff starts the crew. Tasks run in sequential order. When they are all done, you get back a crew output. Result.raw, it gives you the final task's output as a string, and result.task_output gives you a list of task output, one per task. Each task output has task definition, raw output, and the agent name. You can read every agent's work after the run as well. Now, if we compare it with our previous videos in this series, video 3, which was our raw agent, which we built with Python, we only get a string we printed ourselves. In video 4, which was LangChain agent executor, we got result output plus intermediate steps if we enable it. In video 5, which was our LangGraph video, we got a full typed agent state dict with every field, which was our detailed output. Video 6, which is this one about CrewAI, we get crew output with per task breakdown. Each framework has a different answer to the question, what should you get back when the agent finishes? None is objectively better. It depends on your use cases and it also depends on what you need to see after a run. Let's run it now. It's working. Let's look at the output. The first thing you notice is that the output looks completely different from the previous videos. CrewAI has its own formatted output system. Every agent and every event gets a labeled box where crew started, task started, agent started, where the tool execution started. You are not reading raw print statements. As you can see, they are very well structured execution logs that the framework is doing for you. Now, Watch where the researcher starts. So first we print the task, that what is the population of Tokyo, calculate what percentage it represents of Japan's total population. Now this is where the crew execution starts. And then it starts the research agent, which is here, population research specialist. Population research specialist receive its instructions, which is find Tokyo's population with this key and Japan's with this key. It fires 2 web searches. One is for Tokyo's population for the year 2023, and the second search is for Japan's population 2023. Both came back with correct figures. Then immediately it stores those values in the memory, which makes 2 memory store calls for Tokyo pop, which is equal to this, and Japan pop key, which is equal to this. Both confirmed, stored. Then we have completion of this. Then agent's final answer, which says both population values have been stored or found and stored in memory, with Tokyo pop key has this value and Japan has this value. And it's mentioned about that completion of the task. Now compare this with the LangGraph video. In LangGraph, the agent tried to store values before search came back, and it stored empty strings, if you remember, and had to recover by reading from context. Here, the researcher searched first, confirmed the results, and then stored. No empty value, no recovery needed. The role description, that you always verify figures before storing them and you never guess numbers, actually shaped this behavior. Now, look at the handoff protocol here. The research agent has this task completion block, which says the task has been completed. This is written based on the expected output field. Then immediately after that, the second task started, which is for the statistics analysis specialist to retrieve the values and calculate the percentage. Now, when the statistical analysis specialist starts, there are 3 tool calls in sequence. One is memory retrieve for this key, Tokyo_pop, and the second tool call is memory retrieve again for another key, and the third one is calculator. So notice that what calculator didn't do, it did not run a web search anywhere here, and it could not because we did not provide it with that tool. It trusted the researcher's stored values completely and went straight into the calculation. That's the tool boundary we set in the block 4 here. If we go to the agent section, and we have given it a boundary that it can only use these tools. Now get to the final answer. After the calculation, it says the result is 11.1, and then it gives agent's final answer, which says the population represent 11.11% of Japan's total population, and this is the formula used, and these are the values that were substituted, and there is a final answer. One last thing after the final answer is that CrewAI automatically sends a trace to app.crewai.com and gives you a link which you can click and get a visual replay of the entire execution, every agent, every tool call, every output in the web UI. You did not write any observability code here, and you did not set up any tracing library either. It's built in, and in the next layer of this series, which is observability, we'll build exactly this kind of tracing ourselves, understand what's happening under the hood, and connect that to the production monitoring tools. But for now, notice CrewAI ships it out of the box, and that's the trade-off: less control and more built-in tooling. So when should you use CrewAI over other frameworks? Use it when your task naturally splits into roles. If you can describe the work as a researcher does X, and then writer does Y, then a retriever or reviewer does Z, that's the CrewAI. The role model maps directly onto the problem structure. Use it when rule separation matters. If one part of your workflow should never have access to another part's tools for security, for cost, for reliability, CrewAI enforces that at agent level without custom routing logic. Use it when you are building pipelines, not just loops, sequential tasks with clear handoffs, report generation, content pipelines, research, then summarize workflows. CrewAI suits the best. Don't use it when you need step level control. If you need to inspect state after every tool call, trigger alerts in the mid-run, or pause for human approval at specific node, LangGraph is still the right answer. And don't use it for simpler linear tasks. One agent, 3 tool calls, 1 answer. That's the agent's executor territory, as we discussed in the previous video. Don't add role complexity where a single loop is sufficient. CrewAI shifts the question you ask when building an agent system. Instead of what tools does the agent need, you ask what roles does this task require and what should each role be able to do. That's a different design process, and for the right class of problems, it produces cleaner and more maintainable systems. That's the end of this 4-part series on agent frameworks. We first built raw Python agent. Then we moved to LangChain agent executor and we talked about the use cases. And then we moved to LangGraph. And then in this video, we covered CrewAI. We used the same task for all 4 architectures and with 4 different set of trade-offs. If this series helped you, please consider subscribing to the channel. And the most useful thing you can do is leave a comment with which framework you are actually going to use and why.